All right, thank you for joining me today, students from testing. I just want to go over the principles of real numbers. All right, let's get started. So here's the number line. The middle number is called the origin, 0. The natural numbers are the counting numbers, which is 1 all the way to infinity. So 1, 2, 3, all the way to infinity. This here means that the arrow indicates that the number will keep going forever. What else? Whole numbers. So whole numbers is the counting number plus the number 0. So it starts at 0. Okay, so let's see here. For this one, I can do. Let's see. I'm trying to do starts here at 0. Oh, it's not showing. Starts at 0, and it keeps going all the way to infinity. Let me see what else. Absolute value. So the absolute value, it is a number's distance away from 0 on the number line. This is how we represent absolute value. Here you see how 5 is 5 units away from 0. So the absolute value of 5 will be 5. Here, the distance from -5 to 0 will be 5 units. So in other words, the absolute value represents the distance a number is away from 0. And the distance will always be positive. Here we have two numbers that have the same absolute value on opposite sides of the origin. Like I was saying before, the distance is the same, although they coming from opposite directions. Think of you like coming from either from Irvine to school, that's 5 miles, or from Garden Grove to school, that's 5 miles. That's just an average, okay? But that's just an example. They're coming from two different directions. We travel a distance of 5 miles, but when we travel distance, it's always positive. Just because we came from a different direction doesn't mean that's going to be negative. So that's +5, -5. Integers. So integers right here will be all the numbers and the number line including 0. So 0 all the way to infinity and 0 all the way to -infinity. The whole numbers and their opposites. That's basically what integers are. Whole numbers and opposites. Rational numbers. Rational numbers are any number that can be written as a simple fraction. So like, for example, 3 is 3 over 1. -7 could be rewritten as -7 over 1. 1.5 is actually a rational number because it can be rewritten as 3 over 2, 7.25, -3.75, and 1 over 3. Natural numbers, whole numbers, integers, terminating decimals, and repeating decimal are rational numbers because they can all be written as a simple fraction. See how notice that these numbers here, they are written as a simple fraction. Irrational numbers, you guys know the famous irrational number. Any number that can be written as a simple fraction that cannot be rewritten. So, of course, the famous irrational number here is pi. We cannot make an emphasis here on pi. So we cannot rewrite pi as a single number. Pi is an irrational number, so we have to keep it irrational. They did an approximation, which is 3.141592654, and it keeps going, but that's not an exact answer. Radical 17 is an irrational number, which means it cannot be rewritten as a simple fraction. So two examples in this class is pi and the square roots of non-perfect squares. Real numbers. Real numbers are all, you get this question a lot, okay? The GED. All the numbers on the number line. All these numbers right here. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. These are the numbers that we'll be using in this class. All right, so here's a summary of what we learned. Natural numbers, those are the counting numbers. Whole numbers includes natural numbers and the number 0. Integers. Integers are numbers that include the 0, the natural numbers, and their opposites. So we have some negative numbers there. Rational numbers. Rational numbers are numbers that can be rewritten as a fraction, and they have a terminating decimal, so 1 over 2, that's 0.5. 5 over 3, which is 0.6, and so forth. Those are rational numbers. Irrational numbers, famous pi, and the square root of any numbers that doesn't have a perfect square. So like square root of 5, for example. And the real numbers are the combinations of everything here. The natural numbers, the whole numbers, the integers, the rationals, and the irrational. So even the irrationals here, all the numbers that combine are called real numbers. Graph the numbers on the number line. So you guys will pause the video now. Go ahead and do a number line from negative 10 to positive 10, and go ahead and graph them. All right, I'm assuming you done writing them down. So here we go. Number 7. Oh, pretty sure you guys got that one right. Oh, pretty sure you guys got negative 6, right? That's 4.5. 4.5 is 4.5, so it's between 4 and 5. A negative 37 over 4. Okay, you have to do division there. That's negative 1 over 3, which is 0.33. Negative 0.33. Now that's 9.5. 5.9 square root of 3, which is square root of 3 is 1.73. So it's between 1 and 2. Okay, we are done for today. You guys go ahead and practice this. By the way, here are the answers one more time. You can pause the video, make sure that all your answers are good. And then you can do some of this question. Let's do them together. What is the point 0 on the number line? See if you guys remember. Pause the video, or if you know the answer, then keep going. The answer is the origin, you guys. Number 2. What are all the numbers on the number line called? You guys ready? Think you have an answer? The numbers are called real numbers, you guys. So all the numbers between negative infinity to positive infinities are real numbers. Number 3, what is the opposite of 13? Ooh, that's a tough question, you guys. What is the opposite of 13? The answer is negative 13. Feel free to pause the video so you guys can have some time to think. Number 4, what kind of numbers are 0, 1, 2, 3? Pause it, think, reflect. The answer is whole numbers, you guys. The reason is the whole numbers because it has the number 0 all the way to infinity. Next, number 5. A number's distance from 0 is called what? Haha, absolute value. I know some of you got this one right. How do you write 3.8 as a simple fraction in the lowest term? For this one here, to get rid of the 0.8, just times it by 10. So you get 38. And then put the 10 on, times it by 10 on the top and bottom, numerator and denominator. So you get 38 over 10. And 38 over 10, you take half. Half of 38 is 19, and half of 10 is 5. What are the 2 examples of irrational numbers? Well, that was pretty easy. That was the number pi, and you can pick another like square root of 17 maybe. Whole numbers and their opposites are called integers. The whole numbers, you guys, we've mentioned that, and then the opposites of the whole numbers are the integers. Which of those of numbers does 7 belong to? So is 7 a Is 7 a whole number, you guys? Is 7 a natural number? Is 7 a rational number? And is 7 a real number? Yes, it has all these conditions, you guys. It's a natural number, it's a whole number, it's an integer, and it's rational. And it's a real number. It's not irrational because it could be rewritten as a terminal decimal, which is 7.0. And we can write it as a rational number, which is 7 over 1. That is it for today, you guys. Thank you for watching.